Good morning, students. I am Meenakshi, Assistant Professor, Computer Science Department, working in Rohini College of Engineering and Technology. And we are going to discuss about the topics in the course CS 8603 Distributed Systems. So, the last class we have studied about the CORD protocol. So, today the topic is CAN, that is Content Addressable Network. The learning objectives are: we are going to learn about the concepts behind CAN, and we are going to know about the properties of CAN and the steps behind the CAN. So, what is Content Addressable Network? It is a scalable indexing mechanism. It is also used to map the object to their location in the network. Like a CORD protocol, CAN is also used to map a data object to the node. The CAN supports the basic hash table operation like insertion, searching, deletion, etc. So CAN is composed of individual nodes, and in each node we can store a zone of the hash table. By using the greedy routing algorithm, you can forward the request for a particular key. So here we don't need any centralized control. All the indexes are indexed in a distributed manner. The properties of content addressable networks are: it is distributed in nature, it is highly fault tolerant, it is highly scalable, and it is independent of naming structure. It is easily implementable at the application layer. It is self-organizing one and self-healing one. So usually CAN is a logical d-dimensional Cartesian coordinate space, and the space is organized as a d-torus logical topology. So you can go with one-dimensional torus or two-dimensional torus or three-dimensional torus. The D can take any dimension. So we have three components for CAN. First one is set up the CAN virtual coordinate space. Second one, routing the request. Third one, maintaining the CAN. So the initialization of CAN. So every CAN is assumed to have one unique DNS name. So that unique DNS name is mapped to IP address of one of few bootstrap nodes in that CAN. So what is bootstrap node and what is the use of that bootstrap node means, this bootstrap node is only responsible for tracking a particular list of the nodes, and we are believing that these list of nodes are currently participating in CAN. For example, a joiner node queries a bootstrap node via the DNS lookup. So how the bootstrap node replies means, it sends the IP addresses of some randomly chosen nodes. So the joiner may choose any random point in the coordinate space. The joiner sends a request to one of the nodes in the CAN, and it is asking that node for a new region. The recipient of the request routes the request to the owner, which contains the point P. For this you can use a CAN routing algorithm. So what is the old owner is doing means, it splits its region into two halves. One is for himself and the other one is given to the new joiner. So the joiner learns the IP addresses of all its neighbors from the old owner. So we can easily understand by this diagram. So initially one new node is joining into the CAN network. So it sends a request to bootstrap node. So the bootstrap node sends some random IP addresses. So the new node discovers some node. It is named as I, and you have to pick one random point in the space. The node I routes to that particular point x, y Okay, it discovers some node J. So what J is doing means it divides the space into two halves. One is for J and the other one is given to the new node. This is how we are assigning a space to the new node. The new joiner as well as the old owner of the point inform their neighbors about the changes to the space allocation. The overhead of this algorithm is order of D, which is independent of N. So the second task is can routing. So how can routes the request? It uses the straight line path from the source to the destination. So we can use the greedy algorithm. It maintains the routing table. In that table, all the neighboring node details and their logical coordinates are stored. So the data stored in the can is addressed by the name, that is the key. It is not addressed by the location. Okay, that is, we can't use the IP address to locate the data. So here you can use any routing mechanism. So each node maintains a routing table which has all the details about the neighboring nodes. So this is how the request is forwarded. So we have so many P's and we have the query. So this query is forwarded to first node. So if it is not matched, by referring the routing table, the query is mapped to the next nodes. Finally, it reaches the particular node. So here the routing path of length is d by 4 n power 1 by d. So what is the algorithm we used? We choose the neighbor nearest to the destination. So this is the routing algorithm. That is the greedy algorithm. And the final topic is can maintenance. So if the node voluntarily leaves from the network, it must hand over the region and the key value tuples to the neighbor. Okay, so what the neighbor is doing means either it convex the region after merger of rejoins. After merging the regions, okay, so either it can merge the region or otherwise it go with some other solution. So this is how the joining takes place. So for example, if the node 2 fails, its region is assigned to its neighboring node 3. It is one case. If the node 7 fails, the region 5 and 6 get merged and assigned to node 5, whereas node 6 is assigned the region of the failed node 7. Okay, 5 and 6 are merged and 5 takes the charge of 6 and 6 takes the charge of failed node 7. So like that, you can use a load balancing and you can use a reassignment protocol when the node leaves from the network or when the node gets failed. So how can we know the node is failed means with the help of the heartbeat messages. So if we cannot hear the heartbeat message reply, then all the nodes should run a takeover protocol. Okay, we have to decide which neighbor is going to take charge of the failed node. We have to choose the best one. So this is how we are maintaining the CAN network. So with this, we are ending the topic content addressable network. Thank you.